All right, we're starting here with question 1. Hopefully you've read it already. From the last sentence, it says we're asked to predict the difference between the exam scores using a 90% confidence level. So we know right away we're using a confidence interval. If we look, there are two samples of students here, one who slept more than 8 hours, the other who did not. So if we go to Grandma's Best Statistics Recipes, we will see that for two samples, we want to, so here are recipes for two samples. When we're looking at means, the formula for a confidence interval is x1 bar minus x2 bar plus or minus t star times square root of s1 squared over n1 plus s2 squared over n2. The degrees of freedom, and this differs a little bit from what the online text says, but a good estimate of that is to take the smaller sample size and subtract 1. Online they suggest just using a computer. Here we'll just use a rough estimate, which is a smaller sample size minus 1. Alright, so for our test we need to write down first the values we're given. We're given first sample mean is going to be 77.3, and the standard deviation for that sample is 5.2. The second group, the sample mean, would be a 2, is 71.3, and the standard deviation is 6.8. So our formula for the confidence interval was x1 bar minus x2 bar plus or minus t star times square root of s1 squared over n1 plus s2 squared over n2. Alright, so first thing we can plug in the easy stuff, x1 bar and x2 bar, 77.3 minus 71.3 plus or minus, I'll come back to the t star in a second. Let's go ahead and plug in the other stuff. s1 squared is 5.2, and don't forget to square it. Divided by the first sample size was 28. And then the second standard deviation was 6.8, and that sample size was 31. Now we need to calculate t star, and if you remember, we can get t star by going to the z value, or the t and z table. We're looking for 90% confidence, so we're looking in this column. We need to know then what degrees of freedom to use on this test. Now we're told that the degrees of freedom should be the smaller of the two samples sizes minus 1. The smaller sample is 28, so 28 minus 1 gives us a 27 for our degrees of freedom. So if we go back to the z table, we're looking at the row for 27, looking at 90% confidence, and the value there is 1.703. So we're going to use 1.703 as the critical t value. Now you may want to pause this and go ahead and calculate this, but when I work it out, this works out to be a 6.0 plus or minus, and on the right hand side we have a plus or minus 2.67. And that would give us a prediction that we are 90% confident the actual mean difference is between 6.0 minus 2.67, which works out to be 3.33, and 6.0 plus 2.67, which is 8.67. So the actual mean difference between the group sleeping more than 8 hours and sleeping less is somewhere between 3.33 and 8.67. And that's it.